Everybody. For this one, let's see. Let's do another exercise. The problem asks you to sketch the region of the integration of the integrated integral. So this one is also the double integral, dx and dy. Asks you to sketch the region, so you need to plot the graph. And you simply take a look at the dx and dy. This is just the area, right? The dimension square. And what you need to take a look, just take a look at the limit. This is the lower limit of x, and this is the upper limit of x. And this one, the lower limit of our dy, and this is the upper limit of our dy. And for x, you can start from 0 to 6, right? And then next, you take a look at the lower and the upper limit of our dy. So that's you can see that the y maximum is at 2. That's the upper limit. And the lower limit does give you an equation for, y in the term of x. So that's y equal to x over 3, or the slope is 1 over 3. And you have an intercept of x equal to 0. And then as you can see, for x equal to 6, that you just plug in x equal to 6 into y equal to x over 3. So 6 over 3, that's give you 2. So that's why you have two lines, merging here. For y equal to 2, you have a straight line parallel to x-axis. And then you have another line, y equal to x over 3. So this is the region of integration. So you need to integrate, the right triangle. Okay. The next one is the reversing order of integration. What I meant is that when you want to integrate dy dx and you have a difficult time to do that, you need to switch. Instead of integrate with respect dy first, you just do the integration with respect to the x, and then you can do dy later, integration of dy later. For this example, the same as the previous problem. So you see that you need to integrate dy with, like you have variable both x and y. So and you have this one in the term of square root of y to the cube plus 1. So that's give you that's it's difficult to find a solution for this one. So let's try integrate with respect to the x first. So I switch integration. Actually, this one is supposed to be double integration. My mistake. Instead of you integrate dy dx, and then you switch between dy and dx. So you need to integrate with respect to the x first. The other step that you need to do is that you need to look for the lower limit and the upper limit of x. Okay. And because the x is in the term of y, as the term are given, and then you know that you have the line y equal to x over 3. So you can write x in the term of 3y, because later on you need to integrate with respect to dy, right? So everything has to be in the term of y. And then you can write y equal to, that's the y equal to x over 3 is given. And then x equal to 3y. So what you can do, you can find the lower limit and the upper limit. So for that's the, okay, let's see. How do you get lower limit 0 and upper limit 3y for the x? Okay, that's why I circle with the red pen here. For the x, of course, you start from 0 at this point, and then you go up, and then at the arbitrary y, okay, you don't need to put the upper limit of x to be your uh, 6, right? So our x depend on y, and that's in the term of x equal to 3y. So up to upper limit in arbitrary term, that's you put 3y here, because as told you before, later on you need to differentiate with respect to dy. So the inner integration, or the integration with respect to x, should give you in the term of the function in the term of y. So that's why we have our 3y here. That's the, just want to point this out. So you can do straightforward. Now it's maybe simpler. You have sorry, x here, and you integrate with respect to the x. So you end up with x squared divided by 2. And you apply lower limit and upper limit. You have 9y squared, and you also have 1 over 2. And then minus 0. So you have 9y squared divided by 2. And you still have y to the cube plus 1 to the power of 1.5. Now you can work out this one. Well, we need to recall another technique of integration, because you have, you know that you have y to the cube in the square root, and you have y square right here. So I let v equal to y to the cube plus 1, right? And differentiate of v with respect to y, that's give you 3y squared, right? You differentiate 1, that's constant, that's give you 0. And you can write dy in the term of dv, okay? Because we want to change everything from y to v. So you divide, y squared dy, since you have y squared dy here, equal to dv over 3. Now you look for the lower limit and the upper limit. For the upper limit, as the y equal to 2, the result should not have a variable or factors of y or x. It should give you just a number. So you just put the upper limit of y in the term of a number, lower limit in the term of number. In this case, upper limit is 2, lower limit is 0. For y upper limit, because you switch from dy to the v, you need to find upper limit of v. So when y equal to 2, that's give you 2 to the cube, right? So that's give you 8 plus 1, that's give you 9. And then for y equal to 0 here, lower limit, y equal to 0, that's give v equal to 1. So you have lower limit 1, upper limit 9 for integration of dv. And here you already have v equal to 1.5 because there you're put the v equal to y to the cube plus 1, right? So you end up with v to the power 1 over 2 plus 1 divided by 1 over 2 plus 1. And then you can work out on this. Just put the upper limit and then the lower limit. For the upper limit, this one is what? V equal to 9. So 9 to the power of 3 over 2, that's give you 27. And then for the lower limit, for y equal to 0, you have this one, v equal to 1. So you have a lower limit of dv of v equal to 1. And then you plug in this term. So 1 divided by 3 over 2, right? And then this one cancel out. So you have to do 37 minus 1 equal to 26. Okay, that's all how to solve the problem. Reversing order of integration. You switch integration dy dx to be integration of dx dy. Okay, that's all for now.